In this concept, we're going to talk about solving polynomial equations. Let's look at an example. Now, these are all the kinds of tricks that we can use to solve polynomial equations. There are many of them. The best way to be knowledgeable in all of them is to just keep practicing. Okay? Let's look at this example. Solve the following equations. Example 1. X to the fourth plus 18 equals 11x squared. We need to solve for x. Okay? Now, the first step is to write this in quadratic form. And remember, quadratic form is, ax squared plus bx plus c, equals 0, right? So first term is a squared term, and then the second term will be a linear term, right, to the power of 1, and then the third term will not have an x in it. It'll just be a constant, okay? So this is quadratic form. So we have x to the fourth plus 18 equals 11x squared. You might think this is the square term. It is x squared, but relatively speaking, this will be the square term or the quadratic term, because now when we break it, it'll look like this, right? X squared squared, and then 11x squared, right, minus 11x squared, right, which is the equivalent of the x, just x, and then plus 18. So now if you break this, right, which is just what we have here, so x squared all squared minus 11x squared, right, plus 18 equals 0. So it's kind of like the quadratic of a quadratic, right? But that's perfectly fine, because when we factor it, we end up with x squared minus 9, right? Or, we end up with x squared in the parentheses. Remember, whenever we had this and we factored, we had x in the parentheses. But because we have x to the fourth, and this is x squared, we'll have x squared in the parentheses, which is perfectly fine. Okay, it is still considered a quadratic equation. So let's look at what we get. So x to the fourth, when you take the square root of it, you get x squared and x squared, right? So this is what we have here. 18, again, so we need two multiples of 18 that add up to minus 11 when added together. Now, what are these multiples? Well, minus 9 and minus 2, right? Again, you can go through the process, right? So 1 times 18, 2 times 9, 3 times 6, etc., etc. And just add any of these in whatever sign combination, right, to get minus 11. So 1 and 18, there's no way to get minus 11 from 1 and 18. 3 and 6, well, there's no way to get minus 11 from 3 and 6. Minus 3 minus 6 is minus 9. 2 and 9, if you do minus 2 and minus 9, you do get minus 11. So my multiples are, or my factors of 18 are minus 2 and minus 9. So I have x squared minus 9 times x squared minus 2 equals 0. But I can factor this further, right? So now x squared minus 9 is a difference between two squares, right? So which gives me x minus 3 and x plus 3. X squared minus 2, well, 2 can, like if you take the square root of 2, it's not a whole number. But algebraically, I can work with just square root of 2. So we can do this, right? So we can treat this as a difference of two squares and break it down to x minus square root of 2 and x plus square root of 2, which is perfectly fine. Okay? And now from our zero product property, the solution is the zero of all these parentheses. So x minus 3 equals 0, or x plus 3 equals 0, or x minus square root of 2 equals 0, or x plus square root of 2 equals 0. And remember, we said or, right? So the or operand means you have to take all of the signs. Okay, you have to take the union, right, of all the values that you get, or all of the zeros. So the union meaning you just have to take all of them. So you take the 0 from here, and the 0 from here, and the 0 from here, and the 0 from here. And that becomes your solution set. So the solutions are x minus 3 equals 0, x is equal to 3, x plus 3 equals 0, x is equal to minus 3, x minus square root of 2 equals 0, x is equal to square root of 2, x plus square root of 2 equals 0, x is equal to minus square root of 2, which is exactly what we have here. Okay? And again, you can just check the solutions in the original equation, and it should check. Okay? Next example. We have x times parentheses x minus 2 plus x times parentheses x plus 8 equals 2x times x minus 1 plus 8. So the first step is to just multiply using the distributive property. Okay, combine the parentheses and the single term, and then collect like terms together. So let's look at what we have. So x times x is so x times x is x squared, and then minus 2x plus, x times x is x squared plus 8x, right? So this will be x plus x squared, x squared plus x squared, which is 2x, right? And then minus 2x plus 8x is 6x. Okay, so we just skipped the step here. 2x times x is 2x squared. 2x times minus 1 is minus 2x plus 8. Okay? So the next step is to combine like terms. So we have 2x squared and 2x squared. If we subtract 2x squared from both sides, the x squared term essentially goes away. So we end up with 6x equals minus 2x plus 8. We can bring the 2x on the left-hand side, so plus 2x plus 2x. That gives us 6x plus 2x equals 8, because these two cancel out. So we have 8x equals 8, or x equals 1. Okay? And here we have some exercises. Please pause the video, work on these, and come back for the solutions. Okay, so let's look at this equation. We have x to the 4th plus 12 equals 8x squared. Again, the first step is to write it in quadratic form, meaning we subtract 8x squared from both sides, right, to bring the 8x squared on the left-hand side. So we have x to the 4th minus 8x squared plus 12 equals 0. Open parentheses, right? So x to the 4th breaks to x squared and x squared. This whole thing equals 0. We need a multiple of 12, or we need two factors of 12 that add up to minus 8. So again, going through all the possible factors, right? 1 and 12, 2 and 6, 3 and 4, whatever, etc. So we need them to add to minus 8, so you can clearly see that minus 2 and minus 6 multiply to 12 and add up to minus 8, right? So minus 2 times minus 6 is plus 12, and minus 2 plus minus 6 is minus 8. So it's x squared minus 6 and x squared minus 2. Using the same trick that we used in the example that we looked at before, right? The first example, right? Remember when we had x squared minus 2, and then we treated the 2 as a square, right, of square root of 2, right? So square root of 2 squared is 2. We could do the same thing down here. So we'll have, I'm going to continue up here. So we'll have x minus square root of 6, x plus square root of 6. Yeah, this is too big. So x minus square root of 6, x plus square root of 6. And then we'll break the x squared minus 2 into x minus square root of 2, x plus square root of 2 equals 0. Okay? Which means my solution set is square root of 6 minus square root of 6, square root of 2, and minus square root of 2. Okay? Next exercise, we have x minus 1 minus 2 times parentheses 3x plus 1 equals 4 times x plus 2 minus x minus 1. So again, the first step here is to use the distributive property, get rid of any parentheses, and then combine like terms together. So we have x minus 1, we could just get rid of the parentheses, minus 2 times 3x, which is minus 6x, and then minus 2 times 1 is just minus 2, equals 4 times x is 4x, and then 4 times 2 is 8 minus x, and then the minus times negative 1, remember, don't forget the sign. So you're basically distributing this sign to both terms, or you're basically distributing minus 1 to both terms, right? Because there is a 1 here that's not written, but so yeah, you just have to distribute the sign to both terms. So minus x, and then minus times minus 1 is plus 1. Okay? Then just combine like terms. X minus 6x is minus 5x, and then minus 1 minus 2 is minus 3, equals 4x minus x is 3x, and plus 8 plus 1 is plus 9. Okay? Now I want to combine like terms, and what we could do is we can bring these to this side. Why would I want to do that? Well, again, to get rid of the negative signs, right? Because positive is a little easier to work with. So I could do it either way. I could have subtracted, 3x and 9 from here, brought it to the other side, or I can just add 5x plus 3 and add 5x plus 3, right? So this becomes 0, and this becomes 3x plus 9 plus 5x plus 3, which is 0 equals 3x plus 5 is 8x plus 12, okay? Or x equals, so I can subtract 12 from both sides, right? And then divide by 8, so x equals minus 12 over 8, right? Which is also equal to, divided by 4 is 2, divided by 4 is 3, so x is equal to minus 3 halves. Okay, and that's my result. Third exercise, we have 2 times x minus 1 minus 3 times x minus 1 equals x minus 1. So again, the goal is to get the like terms together so we could simplify the expression. So we have 2 times x is 2x, 2 times negative 1 is minus 2, minus 3x plus 3. And then I can bring this to the left-hand side, right? So minus x plus 1 equals 0. Combine like terms. 2x minus 3x is minus x, and then minus x is minus 2x, minus 2 plus 3 is plus 1, and then plus another 1 is plus 2. Okay, equals 0. X equals, bring this minus 2 to the other side, so x is equal to minus 2, and then divide by this minus 2, divided by minus 2, or x equals 1. Alright, this is it for this concept. See you in the next video.